So we are dealing with problem number 3.144 of I.E Irodov, and the problem is stating a parallel plate capacitor is located horizontally so that one of its plate is submerged into the liquid while the other is over its surface. The permittivity of the liquid is equal to epsilon, its density is equal to rho. To what height will the level of the liquid in the capacitor rise after its plate get a charge of surface density sigma? So this is the problem which we have. So let's get started by drawing a diagram of the situation which the problem is stating. So this is the entire situation which this problem is stating. This is the initial situation when the charge on the capacitor is not there, or the charge on capacitor is 0. And then after a while, when this plate, upper plate is positively charged and the lower plate will be eventually negatively charged, then this is the scenario which it is going to look like, that due to this positive charge on the upper plate, a negative charge is induced on the surface of the liquid which is in near contact of this positive plate, and as a result of which a force of attraction will develop and this layer of liquid will rise by a height h. So we are here looking to calculate this height h, and on the other side over here this plate will also acquire an induced charge due to the opposite nature of this negative charge, that is positive charge, and a negative charge which is on the upper plate plus q. So minus q will develop on the lower plate. Now because of the electric field which will be created by the upper positively charged plate and the lower plate, a electric field will be established which will cause a force on this induced charge, causing the liquid level to rise. So this is the entire scenario which we need to understand. Now let's work on the mathematics. So the first thing that we are calculating is induced charge. This is the final scenario. So the first thing which we are calculating is induced charge on the water surface, or liquid surface for that matter. So liquid surface will be nice because water is nowhere mentioned, so we should write it as liquid surface. So liquid surface is equal to q 1 minus 1 by k, or epsilon r, which is the dielectric constant in this case, and therefore we can say the charge on the other plate of capacitor, on the other plate of capacitor. So if we are calculating the charge on the other plate of capacitor, so if this is positively charged, it will be having a negative charge minus q, and if this is negative charge, which is the induced charge on the upper surface, then a positive charge will be on the lower end of the plate where the liquid surface is in contact with, thereby creating a total of minus q plus q minus q by epsilon r. So the charge value will become q by epsilon r with a negative sign. So this is the scenario which we have. So this is the charge which is going to experience the force due to the electric field, and the electric field is created due to the positive charge on the upper plate and a negative charge of minus q by epsilon r on the lower plate, and the direction of electric field will be directed in the downward direction. So this will be the net direction of electric field, which is sum total of the electric field due to positive plate and the negative plate. So if we calculate the total strength of electric field, so the total strength of electric field is equal to sigma by 2 epsilon naught due to the upper plate, and then this will write as sigma 1, and then sigma 2 by 2 epsilon naught on the lower plate, and hence we can say that it is equal to q by 2a epsilon naught, and then we write another one as q upon 2a epsilon r epsilon naught. So this is the total value of electric field which the induced charge on the surface is going to experience. So q upon 2a epsilon naught 1 plus 1 by epsilon r is the total value of electric field strength. So therefore the electric force on the induced charge. So if we calculate the electric force on the induced charge, so we say that the electric force on the induced charge is Q 1 minus 1 by epsilon r, which is the induced charge value, and then we multiply this by the value of electric field. So Q upon 2a epsilon naught 1 plus 1 by epsilon r, and this is going to look like Q square by 2a epsilon naught 1 minus 1 by epsilon r squared. So over here we say that this is the force on the induced charge, and this is the reason why the liquid layer will lift off, and it must be equal to the weight of the liquid that is raised. So density into cross sectional area into height. So this is the mass times g, which is equal to Q square by 2a epsilon naught 1 minus 1 by epsilon r squared. And from here if we calculate the value of h which we are looking for, so h is equal to Q square by 2a square epsilon naught rho g, and then we have epsilon r square minus 1 by epsilon r square. So over here in the problem it is stated the value of sigma is stated rather than the value of charge and area. So we are taking this as sigma. So we write it as sigma square by 2 epsilon r square epsilon naught rho g, and in the numerator we have epsilon naught square minus 1. So this is the final answer for this particular problem which we are looking for. So if we again understand the basics of the problem, so the basic of the problem includes that we initiate that a positive charge is there on the upper plate having a surface charge density sigma. This positive charge will induce a negative charge on the surface of the liquid, as a result of which this liquid layer will rise because of the attractive force between them. And then the lower plate is also getting an surface charge because of this induced charge. Some charge will be induced on this surface, and then followed by this a negative charge is also on the lower plate because of the upper plate charge, and therefore we calculate the total charge on the other plate of the capacitor as this value, and then we calculate the net electric field strength due to both the upper plate and the lower plate, and then we calculate the electric force which we equated with the weight mg of the liquid which is raised to calculate the height h of the liquid, which turns out to be this value. So this is the problem, which is problem number 3.144 of I.E Irodov. I hope you like the content. Please like, share and subscribe the channel for watching more such videos.